Okay, let's implement this backward method together. The loss should, the upstream gradient should go first to the loss layer. And this loss layer receives the upstream gradient and calculate its own gradient. And then we pass this gradient to out layer. And after that, we need to divide VA by 2 because it passes through two paths, H1 and H0. So you should divide this gradient by 2 and then pass this gradient to layer 1 and layer 0, like this. And because this one receives context and target, it doesn't have to flow gradients to the downstream path because it's already connected to the last node, the input, context, and target. Therefore, we're going to return nothing. So that is the implementation of simple CBOW. And we can also implement simple skip grab. We also need to implement the initializer. We also need to implement the forward pass. It receives the same inputs as CBOW, context, and target. All right, let's implement the initializer first. We basically do the same thing. We first need to weight initialize. W in is 0.01 times MP random, rand and VH. And W out, because we are outputting V, we change the order, H and V. And after initializing the weights, we need to create layers, matmul, W in. However, in this case, we're receiving target, and target is just 1. However, in the case of CBOW, it receives multiple contexts. So in the case of CBOW, we created multiple in layers, but in the case of skipgram, we don't have to create multiple layers, in layers, but just one. And out layer, matmul, W out. And what we are going to do is create two loss. Because we need to predict two contexts. Context from the left side, context from the right side. And we do basically this job for every layers we are creating or implementing. In layer self, out layer, and self breadth, layer breadth. And for external usage, we need to create word facts and this is represented by word in. All right, and you can implement forward and backward on your own, referring to the implementation of CBAP. All right.